Hello, everybody. Welcome to another Tech Tuesday live stream. For those of you who don't know me, my name is Justin Swart, and I will be your presenter this evening. So, today, I want us to go through two different ways of rolling back your work when you are currently working inside of a Git repository. So, these two different methods are called Git Revert and Git Reset. Now, we will be going through how you use these different methods and also when to use either one. So, just a little note before we start. I won't be going through some of the basics of Git, such as what a working directory is or what a staging directory is. If you would like to catch up on this, then we will link our Git Basics video below after the stream has ended. Okay, so before we start, I would like to explain what these two different Git tools do. So first we'll talk about the git reset tool. Now, when using this command, you would specify a commit that you would want to reset to in your repository. So basically what would happen is you would specify a commit lower down your repository branch, and then all the commits that was ahead of that would be reset. So you would be left with only the work that you have in the commit that you specified. Now, this also differs depending on which option you add to the git reset tool. So these range from the soft command and the mixed command, and then you also get the hard reset command. Now, these are the different levels of data loss you would experience when using the git reset tool, ranging from soft, where you would lose the least amount of work, and hard, where you would physically lose all data up until the commit that you've specified. Now, the other tool is Git Revert, and it works almost the same as Git Reset. So basically, you would use it the same way by supplying it a commit, and then the only difference now is instead of rolling back all the commits ahead of that one in your branch, you would take the commit that you specified, and all the work that was inside of that would get inverted. So if you added a few lines of code and you added a file to that commit, what now will happen is those lines of code would be removed, the files would also be removed, and this new data will be added to a new commit and added to the top of your branch as the new head commit for that branch. Now, what makes this useful is that you retain all the history in your Git repository. So you don't lose any commits. You also don't lose the commit that you actually reverted. So later down the line, when you actually now want to get that work back, you don't have to start from scratch and write all that code from memory. You could go through your Git commits, check the work you did in that specific commit, and then just re-add that. And what actually also makes Git Revert useful is you could run the revert command on an already reverted commit to just undo whatever you reverted initially. This will make a lot more sense later when we actually get to the examples. So let's actually start off by doing some examples with the git reset command. Now, just another note, we will be using very basic examples, and when you're working in a bigger project, you would basically you would just go about using the reset command the exact same way that I'm doing it now. And also, I'm not going to be using a remote repository. But if you are using a remote repository, it would just work the same way. So after you've reset or you've reverted, you can just push all of that latest commits that you have now after you've done your reset to your remote repository, and that should reflect correctly. Okay, so yeah, let's jump off. Um, I've started by just creating a folder for us. We're going to be doing this all from scratch right now. So first off, we would like to actually init a Git repository here inside this folder. Awesome. Okay, so get is just basically telling me that I have an outdated naming structure. The latest way that Git names its master branches is not master, but actually main. So let's just change our branch name to fit that, just so that it looks a bit nicer. Awesome. Okay, so now we've initialized our repository. You can see nothing happened, no commits yet. If we actually list our commits, we don't have any. So we are now left with an empty repository. So for now, we just like to add some files that we can actually test these reset commands on. So for these files, I will be making frequent commits just so that we have a lot of commits to actually test around with. Cool. So yeah, let's start off. We'll create a file called manipulations. And inside of that file, we'll just create a function that removes white spaces from strings. So remove white spaces. And this function will just take a value. And then it will return. What's that method called again? Trim. That's it. It's got this function wrong way around. Sorry about that. Here we go. We will just have it like that. Awesome. So this is just an example. Nothing. We're not going to use any of these methods. We're just going to be using the git reset commands on them. So we're going to be adding frequent commits. So let's just add that. Make a commit now. Just say future manipulations. And then inside there, just say added manipulations file. That's our starting point. We have that now. So if we go list anything, we'll see now we have one commit. And we'll also add another file right now. We can just call that operations. I think that should be fine. And we'll just add one thing and just add a variable here, sum a, b, and that will just return the sum of whatever we give it. And here we can go again, git add, and we'll just add that commit. Call it feature operations. Added the operations file. Awesome. Okay, so we only currently have 2 commits. I think that's a little bit too few. So let's just add 2 more methods here. Call divide, and just take 2 numbers and then do a division on those numbers. So we'll return a divided by b. Here we go. Create a new commit for us. Name it added new operation divide, and then we'll do one last one, and that would just be the product. Why not? And we'll use 2 values and then just return the product of those 2 values. Awesome. Okay, so you might notice that I did make a mistake in this manipulation file, but that's gonna come into play a little bit later when we actually talk about git revert, and that's also why I made that commit very early in our structure, just to show you the power of git revert. But that's for a little bit later. Okay, so let's just add this final commit that we made now. Okay, I did save that. And we'll call just this future operations, and then just call it added the product method. Here we go. Okay, awesome. So now if we look through our commit history, we'll see that we ended up with 4 commits. First one being our initial commit, and then all the ones we added upon that. So let's talk about the git reset commands. So our first option for the git reset command would be the easiest one to understand, and that is basically the git hard reset. So what this does now is if you use the command and you specify any one of these commit hashes to it, all the commits above it will actually fully be removed. The data inside of it will be gone. You won't ever be able to retrieve that work again, except if you're in a remote repository and you only hard reset locally, then you can just pull that back from the remote repository. But in this case, I'm just going to show you what happens when you use git reset hard in your current repository like this. So let's say that product method that we had that we added, we along the line of our coding session we saw that nobody's gonna use that method. So we would actually just want to completely scrap that. So we would go and take this commit right before that one that we added, and we would actually now say git reset. We would give git reset the hard command, which means just wipe all the data, completely lose that, and we would specify our commit. So if we do this, if I run enter now, you'll see our head is now at the commit that we specified. So what git now actually does is it takes the commit that you specified and creates the head reference for your branch to that commit. So git completely loses all reference to all commits that was ahead of that. And as a plus with hard reset, it physically deletes all of that data. So you would think that this is actually a really useless method or a dangerous one, but if you know how to use it in your workspace, it's actually very, very, very useful. Okay, so just to show you what happened now, in our git branch, all our commits, now you can see the one that we specified is currently at the head, and all or at least that one commit that we had above it, it's completely removed. It doesn't exist anymore. We can't find the data. It's just completely obliterated. So in cases like that, it could be useful, but mostly the way you would use it is, let's say you're working in a big project and you have a database schema that it's not added to your like git ignore files. So every time you run a migration or anything like that, your database schema file will update, and that's not like something you really care about. You didn't make any changes to that branch. You now currently you're just testing it, and now that you run your migration, something like this would happen. Let's just add something random. Let's say this is our schema file, and after we ran our migration, it got updated with this. Then you would see that, okay, if you're on status, you see there is a file actually now in your unstaged directory. And what this would actually stop you now from doing is now you won't be able to move around to different branches and stuff like that to actually, to test different files and different branches, because you're left with this file, and you're actually going to have to go and delete the file or delete the changes that was made by the migrations. But you don't want to do that. So the easiest way to basically just reset your repository to the current state, if you made a lot of changes and you don't care about losing those changes, you just want to start over. What you would do is you would run the git reset command, specify hard reset, and in this case, I'm just going to use the instead of supplying it the commit hash, I'm just going to say I want to revert or reset. Sorry about that. Reset to the head of the branch. So this basically, before I run that, so you can know what that specifies, is if I run the git list command again, instead of now actually just using the commit hash, I'm just specifying I want to reset to this head command. So let me run that. Git reset, and we'll use a hard reset, and we'll reset to our head commit in our branch. So we'll do that, and now you can see all of that modified changes that we made. That's completely scrapped now. So with the git reset command, that's basically the most use you would get out of it, is resetting the state of your current working directory, or if you want to scrap just a bunch of work. And yeah, that's basically the extent you would use that to. So moving on from that, we would actually now go to the mixed command. So the git reset mixed command is by default what git uses when you just specify git reset. So if we go git reset, just like this, by default, without passing in an option, it would just be git reset mixed. So the difference between hard reset and mixed now is that when you use the mixed reset, you don't lose the work that you now reset to. So if we go ahead and list now this, and we say we want to mix reset to this commit now, the one that we just initially added that operations file. If we want to run a git mixed reset there, we won't actually lose all the data. We would lose the reference to the commits above that commit that you specify. So our head would now be attached to this commit, and the reference to this commit would now be scrapped. But all the work done in that commit would still be saved in your current working directory. The only thing is now the work would be unstaged. So Git currently doesn't have a reference of those files, so you have to physically add them back again to your repository. This will make a lot more sense once I actually run the command. So let's just specify this commit, and then we'll go git reset. So since mixed is the default option for git reset, I'm not gonna specify mixed here. That's just unnecessary. I'm just gonna go git reset and use that commit hash now. So you'll see if I do that, one of our files gets unstaged. So this is the work that was done in that commit that was just above the one that we specified, where we added the initial operations file and all the work that went into that. Now, if we run git status, you would actually see we still have that work. If you look at our operations file, you'll see that we still have all the work left there in our working directory. But now if we list our branch and all the commits in it, you'll see that we've lost reference to that commit that was just ahead of it. And our new head of the branch would be the commit that we specified. So what you can do now is literally just add that work back again, if that be the case. If you want to maybe actually further modify it, we can go ahead, remove that method. You'll see that, let me just clear this console, see better. See that we are in status, it's still in its modified state, in unstaged. Now we can go ahead and give git the reference to that file. So if we do git add and we run git status again, you'll actually see that now, okay, cool. Our work has been staged and it is now ready to be recommitted. So that was a very small example for the mixed command. But let me actually show you a useful reason you would use this. So let's go ahead and then just commit that back. Actually, you know what? Let's add that back. So we have some more work to check on. Git add all. Run a commit. Gem. Reset. Undid. Reset. Okay, cool. So if you go list, okay, that's nice. We have this, and we have all of our commits back again. So let's add some work to actually demonstrate what this does. So if you, let's say now you're busy working in your directory, and you would go ahead and add a method again inside of this operations file. We'll call it let subtract. That's a good one. let's subtract equal to A, B, and then we'll go ahead and make a mistake here and say B subtract A. So we can immediately see that's wrong, but as we were coding this, we didn't really notice that. And now, without committing, we'll move on to a different file. So we'll just create another file here, test.js, and inside of this file, let's just create a bunch of variables. Why not? Test. Whoops. Go like that. And that. Okay. There we go. So now we have two files, and then without actually us reviewing that operations file now, we're just going to blindly commit this work. So we'll go clear, git add, all, we'll do a commit, call this multiple, and then inside of that, we'll just say added multiple functions and a new file. Don't mind the spelling. That doesn't matter right now. Okay, cool. So now we'll go ahead and list our commits again. Here we go. So you'll see now we have our latest commit, which is where we added that function, but the function that was done wrong. And we have our all of our previous commits in that state. So with the git mixed command, what you can actually do now, so if you have a bigger project that you're working on, in this case, we've only worked on 2 files. So you can obviously see that if we go to this operation file, oh, okay, well, we don't want to go B minus A, we actually want to go A minus B. But because this is like a very, very small project, we can literally just flip that and make a new commit with all that work. But if you're in a very big project and you've done changes to like 16 files, and about 5 of those files you realize, oh, you know what, I actually don't want that work that I just added there. You would then use the git reset mixed command. So we'll go ahead and open up our git list, and we'll see, okay, in this commit is where our error lies, and we would actually now want to go back to our undid reset commit. So we'll go ahead and copy that hash, and we'll just go git reset, use that commit hash, and then you'll see, oh, okay, cool. So another thing that happens with the git reset command, because all of the work that you did in there gets unstaged, the same thing happens for files that you added new. So any new files don't get tracked, they become untracked again. So git just loses all reference to that, but doesn't delete the work. So if we run our git status command, we'll see we have our operations.js file there. That's where our error lies, and we want to go ahead and fix that error. And we also have our test.js file. That's the one that we added initially. There's nothing wrong with that file, so we want to keep all the work that's in there. But we want to change now the operations.js file. So we can go ahead and in this file go A minus B again without losing any of our work. We just fix that file. And now you'll see if we add all of this and create a new commit, call this feat multiple again, added new file and methods, and we save that. So if we now run our git list to check out our commits, we'll see that we basically now just replaced that commit that we wanted to be scrapped with the fixed work, and we didn't lose any of our like the file we just added, the test.js one, or any work in our operations.js file. If we did more than just add that one method, we just took the head reference of our branch, the latest commit, and we just moved that reference to another commit and lost the reference to all the commits ahead of that. And by doing that and just having our work unstaged, we're able to now modify and fix whatever issues lies between those commits and or files that were unnecessary, we can remove them, and then just create one more single commit that now actually has the fixed work. Um, and yeah, okay, that's basically the extent of git reset mixed. The only thing to recap what it does is the commit that you give it, it changes the head reference of your branch to that commit, loses the reference to all the commits ahead of that, and takes that work that was done in those commits that are now lost, puts it in your working directory, but it makes it unstaged. So Git now has no clue what actually those files are. So you have to physically go git add and then add those back to your repository. Okay, that's basically the example for git reset mixed. There's not really much else you can do with that. So we'll be moving on now to git reset soft. So git reset soft and git reset mixed are almost one in the same. They basically do the exact same thing. The only difference is now that when we used git reset mixed and we saw that, okay, our head changes to that commit we specified, but we lose the reference to all of the other commits. That exact same thing happens when you use git reset soft. The only difference now is where in git reset mixed, our work that we did gets unstaged. If we now use git reset soft, all of that work will still be in our stage directory. So Git will still know, oh, okay, he added this file to the repository. He added these lines of code to the repository. That would not differ. Only once you go and physically change around in the files that you committed, that's the only time they will actually be unstaged again and changed. So a very good use for this would be something we call squashing commits. Now, that is when you have a bunch of commits with like just little pieces of work inside of them. It doesn't necessarily need to be little pieces of work, but it's usually most useful for that. You would want to go ahead and take that whole list of commits that you've just made and squash them into one single commit containing all of the work that that has been done in that group of commits. So if we go, let us do that. Let's create a bunch of random commits. Okay, we will leave that file out for the revert. So in here, let's add a double, call it 0.5, and we'll actually add that. Go ahead and create a commit. And we're just going to be doing a bunch of copy and pasting right now. Commit, junk, because I really don't know what to name this. Junk, added some variables. There we go. So we did that. Now we're just going to go ahead and repeat this a whole bunch of times. So let's go ahead and copy all of this, paste it there. And we'll just run these exact same commands again. We'll do 2 more of these, I think would be enough. Take that, add the work, create the commit. I'm not changing the names because that's just unnecessary right now. Add another one, add all the work, and then also do a commit again with all that work. There we go. And now, if we see, we open up our commit list, we'll see, oh, okay, we have 3 commits now that are like each of them just have 3 lines of changes. That's unnecessary. Why don't we just take these 3 commits and make them one? So that is why where git reset soft comes in. So you would now go, I forgot to copy that commit. So now we see we want to take this commit, and this commit, and we would like to squash them into just one commit. So what we would do is take the commit right before that, copy that hash. There we go. And we would just go git reset, specify that we want to do a soft reset, and just paste that commit hash. Once we run that, and go git status. Okay, let's first run our list. Um, if we run git list, we'll see the exact same effect happened that happened when we used the git reset mixed. Our head has now changed to the commit we specified. All of those prior commits gone. But if we run git status, you will see that now instead of actually having that file unstaged or untracked, it's actually been staged now or tracked, just depending. In this case, we just modified the file. If we actually added the file during one of those commits, you'll see it would just come under tracked, and you'll see the file there. In this case, we just have this test.js file, but we see all of our work is still inside of there. Now, without actually having to add the work, because Git already knows now that the work has been staged, we can just go git commit, or actually just so that we don't have to type all of that stuff in again. We'll just use the exact same message, git commit, and once we run the list command, we'll see that now all of the work that we did in those 3 commits still actually is in our working directory and in our Git repository, but we just shove them all into one single commit. So to see this also, you can just go ahead and copy the hash for the commit right before it, and you would do something like just running a git difference on it, on that commit and the one prior to it. So you would go like that, and you would see, okay, we now have a single commit, but that single commit has picked up that we have all of these new changes instead of having them all in separate commits. There we go. Okay, so yeah, that's basically like also the only really good use I would see for a git reset soft command. You could see that when using git reset soft and just plain git reset mixed, they're not very volatile, so they're very safe to use. You know, you won't really ever lose data when you use git reset by default, or if you use the git reset soft command. The one that you definitely should be careful about is the git reset hard command. As you saw, when using soft and mixed, we don't really lose any data. We just roll back our commits all the way down to the one specified, but still keep our data, which we can then do whatever we want with, delete some of it, manipulate some of it. And then by using the soft command, we can just combine a bunch of them. But git reset hard, that's a very volatile command. Using it, you could, if you specify the wrong commits, you could lose a lot of work. So you definitely need to keep in mind how you're using it. So that's why it's usually just useful for reverting your working directory in the state that it was, instead of actually just removing a bunch of commits from your history, because that's just unnecessary. Now, moving on from this, we're going to start talking about the git revert command. Now, this is definitely one of my favorite git commands, because it does what you would assume git reset hard does to a commit. You know, you think you specify a commit, and you want to reset that commit. You would think that the data in that single commit would just be removed and everything else would be kept intact. Which, as you saw when we used the hard reset command, is not the case. Everything just gets wiped completely away. Now, when using the git revert command, when you specify a commit, so let's say that now this is where that file we created that was wrong comes into play. So let's say we've done all of this work, and we see here along the at the end we see, oh, okay, in this commit you see feed manipulations. In this commit, we actually now added an very problematic file. So if someone ever tries to use that, it's never going to work. It's gonna break because it's not made correctly. So what you would do if you would like to actually just take that single commit and remove all the work you did in that one single commit, you would use the revert command. So we know that in this manipulations commit, the one we have here, that's basically our initial commit. We want to take everything we did in there and just completely erase that. But also, it would be quite nice if we didn't lose any history in our Git repository, because then later down the line we can go back to that, try and see if we can find a solution to that, and fix things. So what you would do to actually discard the work from that commit is copy it. We just copy that commit hash again. So just like the git reset command, except now we're not going to specify any options, since git revert doesn't have a lot of options. I'll go through one a little bit later at the end of this example that you actually might use. Yeah, okay, let's say we want to take this commit that we have here and we want to remove all of this work. What we would now do is say git revert. We would specify that commit. And as you see, okay, so git just brings us up a little bit of information. It says what we're going to do now is we'll call your commit message revert. And inside of that revert commit, it just says, okay, you reverted this commit, which is the as you saw, the one that we actually wanted to remove, and then it just gives you the actual commit hash, and inside of here is the actual information you want. You'll see that now the only thing that happened was the manipulation.js file got deleted. Now that's actually really cool, because as you can see, nothing we did after that commit actually has been changed now. Only the work we did inside of that manipulations.js file got deleted, because since we added them in that commit, what git revert does is it runs the inverse of that commit. Now it literally just takes the inverse of all the work you did inside of that commit, and it's going to now create a new commit for us at the head of our branch. So let's just go ahead, and we don't want to change anything here. We're fine with naming it revert, all that stuff. That's good. So we'll do that. And now if we, okay, so you can see in my editor that this manipulations.js file has been deleted. The work inside of here obviously will also be gone. So if I remove that, you can now see that it's completely been banished from my working directory. And if I go git list, you can actually see that instead of actually rolling back my head reference now to that bottom commit that was specified and losing all the other work, all that was done was a brand new commit was made that contains the inverse of the commit we specified. So like I said, if you add work, that work gets removed. If you add files, those files get removed. And all of that gets added to a new commit now at the head of your branch. Now, this is very cool, because now down the line, let's say weeks into the future, you go back and say, okay, you know what, we would like that manipulation file back, but we don't want to really spend time rewriting all of that. We just like to solve the issue. Now we can actually go to this commit and see if we run a git difference on it. We'll see that, okay, we're just going to have to go to the reference of it. Here we go. If we go to the reference of it, what was deleted, to make this a bit simpler, I don't know why I went all the way down. We could just use the one prior to the revert we made. Take that one. We'll run a git difference on that. And then you'll see, oh, okay. So what happened in this revert was this function got removed, as well as this file. As you can see, delete file mode. This file was specified to be deleted, and then these lines of code were now removed. You can see that. So what you can do is just copy, paste that back into your working directory and fix it however you want. And that is without actually now losing any of the history inside of your repository. Whereas, like you saw, if you use a git reset hard, everything just gets wiped. So yeah, that's the cool thing about git revert. It just takes the work, creates the inverse of that, makes a new commit, attaches the head of your branch to that commit, and that just becomes the new state of your repository. No work has been lost, only reverted. So the cool thing about this now is, let's say after this we've done quite some improvements. Like we've added these. Let's add some more functions. I'm just gonna reuse these. We'll add that. We'll create a new commit now. Say functions added more functions. There we go. This is bothering me. There we go. Added more functions. We'll do that 2 more times just to simulate work actually being done in this directory. There we go. Add that. Added even more functions. And we'll just go to a new file right here. Add some more functions right there. Another commit. They won't stop. There we go. And now if we open up our git list, you can actually see, okay, we have all of those new commits that we made. And in here, this is important, we see, okay, we have our revert commit here, which we used to delete this commit's data, or just inverse it. So now we're 2 weeks into the future. We would actually like to have all this data back, but we're lazy. We don't want to go ahead and copy and paste all of the data. That's the work we don't want to do. So you can actually run a revert on a revert, which still does the same thing. So in this revert commit, the information that lies in that commit is the manipulations file has been deleted, and inside of that file, those 3 lines of code have been removed. So if we run a git revert on this commit, the inverse would happen. So the manipulation file, instead of being deleted, would get re-added, and then those 3 lines of code that were removed would then also be re-added to our repository. So to test this out, just to show you guys I'm not lying, you would go ahead, take that revert that we made, you would copy the commit hash, and you would go git revert, specify that commit, enter all the information you want to see here again. So now you can see a new file has been, you can imagine if you keep reverting reverts, there's gonna, your message is just gonna end up being revert. So a total amount of 2 times reverting something, that would kind of be the perfect size. Anything more than that, then you'd probably start thinking, I'm doing something wrong. So now inside of this information, we can actually see a new file has been added, manipulations.js. But the key thing now is we want to see that the data inside of there has been added back as well. So let's just go ahead and exit this message. There we go. Let's first run our list. There we go. We see we now have a new commit that's at the head of our branch. This is the revert commit. So whatever we reverted here, we're putting that back. We're just placing all that work we removed back, but we're keeping our git history in a persistent state. We're not going ahead and unnecessarily removing things. We just changed that single commit that we wanted without changing anything else in our repository. So if we go back to this manipulations file now, we'll see, okay, it has been added back. Now I can start thinking, how can we fix this? Oh, okay, we can just add an equal sign. Oops, I forgot that. You can go ahead, do that. Do a git add on that commit. Let's call that a fix. Manipulations. Fixed issue from before. And there you have it. Now that's how git revert works. So you can see why that's a really nice command to use. So what a lot of people, get confused by git revert is they think that let's open up our list here. They think that if you say git revert and you specify, just this commit, just a random commit, usually you'd think, oh, okay, that means now that git will revert my state of my repository all the way back to that commit. But that's not the case. It just takes that single commit and reverts the work done inside of there. It just inverses that, puts it into a new commit, and you're ready to go. Nothing in your Git history has changed. You can go on with future work, and then you'll always know that oh, okay, I couldn't have broken anything now before. I only did this revert. So it's very useful for keeping your Git history clean and persistent. But also, if it's very useful for manipulating that history to just take single parts of it and just completely remove it without actually removing that commit. And that's okay. So that's basically Git revert. When you actually run it practically like this, you can see that it's very easy to use. It's definitely not something you should be afraid of. It's something you should definitely use in your repositories if you pick up issues and you don't know how to get those issues out without actually physically going to your files, searching for that bug, and then removing the data line by line, and then creating new commits. You can just search for that commit where the work was done, run revert on that, and then boom, it will get fixed. And then you would still have that persistent state in your Git repository where that commit you just reverted will still lie. So you can still see, oh, okay, previously we did this commit, this was wrong, don't do that again. And that's basically all for Git revert. Now, the one thing that I'm not really going to go into in here is when you're running Git reverts on merges. So that works slightly differently. Because since if you merge two branches and you it doesn't really matter if you have a conflict or not, it just behaves the same. If you merge two branches and you would like to run a revert on that merge that you just made, you would have to specify git revert m. You would have to specify m, and then in that for that m you give an argument which is just a number. So if you say git revert 1, it would basically go ahead and take the merge and revert it from the side that you of your current repository. It would go ahead and revert it back to the state that your current repository or your current branch was. If you use git revert m and use a higher number, it would go ahead and then use the branch you actually pulled in, and it would revert the work so that it would match the branch that you pulled in. Because when you're running git revert on merges, Git doesn't by default know which side you want to go to when you're working with multiple branches. So you would have to go ahead and specify that yourself. But other than that, it still works exactly the same. It still just takes the work from that commit, inverts it, but now when you need to specify from which branch you want that invert to happen, so that it can actually maintain its persistence. But okay, but yeah, like, other than that, that's basically all information I can actually give you on using git reset and revert. So basically, just to do a very quick recap on all of that, if we bring up our git list here, if you use git reset hard and you specify a commit, in this case this one, Git attaches the head reference to that commit and completely wipes all the commits ahead of that. The data, everything. If you use git reset by default, or the mixed option, you add that. If you specify this one, same thing happens. head gets attached to that commit. Um, Previous commits get wiped, but your data that were in those commits now gets set to your staging directory, so you can manipulate them however you want. If you use git reset soft, same thing happens. Head detaches from the commit it's currently at, attaches itself to the commit you specified, loses the reference to the commits above it, and instead of having your work unstaged, your work will all still be added to your Git repository in the staged section. So that's basically when you think about using Git reset, you would think about rolling back everything from a certain point at the top to a point that you specify, just rolling back all of that stuff you did. When you think Git revert, like we just explained now, you would think take a single commit in this list and just remove the changes or add the changes that were removed inside of that commit to a new commit. And in that way, you maintain much better persistence of your Git history. But yeah, that's about all I have to say about Git reset and Git revert. I really hope you guys can find some use in this video. I hope this made you a little bit more comfortable with using Git reset and revert, and hopefully it took away some confusion from the differences of Git revert and reset, and when to use them. But yeah, now thank you guys for watching the stream. Really hope you enjoyed it, and stay tuned for next week because we have a really good Angular demonstration coming up, and I think everybody would just really like that. But other than that, have a nice night.